Good morning, everybody. Today we're going to go over basically the rules around inverse trig functions, including the domain and range, and kind of why we do it this way. It's not as cut and dry as just reversing the process. We need to go over it and just make sure that we understand all of the rules and nuances to trig functions and their inverses. So let's get into it. So to kind of illustrate the problem, we're gonna create the graph, and I'm gonna just do a little bit spread out, and I'm going to make each a quarter, pi over 4. So pi over 2. I'm gonna make this 1, and another pi over 2. So just graphing sine as usual. And I think if you do this, it should go from negative pi to 5 pi. So you get your entire instructions as asked. And just kind of. Okay. So here is sine of x from negative pi to 5 pi. And the question asks, does it pass the horizontal line test? And this is the biggest issue within inverse trig, is that no, it doesn't. The horizontal line test, if you remember, is does it go through both, or does it go through two coordinates if I draw some horizontal line? And if I can go through two coordinates, then it doesn't pass. And in this case, anything from -1 to 1 is not going to pass because it's going to go through at least 2 points, and it's going to be cyclical. Even if I go through 1, it's going to hit all of those maximums. So this is definitely not going to pass the horizontal line test, just because there's so many horizontal lines that go through multiple points. And if you remember, the horizontal line test just means that if it doesn't pass, then this function, the inverse of the function, will not be a function itself. So we would like the inverse trig function to be a function. Otherwise, we couldn't use inverse trig function. We would just have to work through it a different way. But it's helpful if we have functions, especially if we want to use tools like a calculator, because your calculator doesn't like having non-function. It pops out one answer. So your calculator wants functions. You want a function for this reason too. It just kind of simplifies things. So we need to narrow our vision of the function. We need to restrict the domain of the sine function. And picking that restriction, there's a lot of answers you could go with if you wanted to pick your restriction. But basically, you want to have a minimum to a maximum, or a maximum to a minimum on your range. So the one we go with is negative pi over 2 to pi over 2. The reason for that is it covers everything from -1 to 1, and it goes through 0, 0. So it goes through your starting point, which just feels like a natural thing. You don't want to start over here at pi over 2 and go to 3 pi over 2. You definitely don't want to start at 3 pi over 2 and go to 5 pi over 2. You kind of want your range of, your domain to go through your y-intercept if possible. If it's not possible, then obviously you can't. You need to choose something else. But this one we can. A lot of people get confused because if you're looking at a unit circle, this is the portion that we're concerned about with the inverse sign. Where a lot of people may want to choose quadrant 1 and quadrant 3, but that's discontinuous, so it just raises up another issue of not necessarily the cleanest function out there. So the cleanest function is starting at negative pi over 2 and going all the way to pi over 2. So we can graph that, just basically copying this, and like that. So this is sine of x from negative pi over 2 to pi over 2, and we can use this as as our inverse trig function sign, and it just makes it so it's 1 to 1. We need to, so going through your purple sheet, just make sure you're answering all of these. But from negative pi over 2 to pi over 2 for sine, because it covers the minimum to the maximum of a cycle, and it passes the 1 to 1. It's 1 to 1 if you do it this way, meaning that it passes the horizontal line test as long as the vertical line test. But because of this, the domain in the range of inverse trigs matches the domain and range of sine. So the domain of the inverse trig function sine is negative 1 to 1. I can't get anything out of sine that's outside of that. And then negative pi over 2 to pi over 2 is the range of sine, because that's the domain of sine restricted. So looking at that, you may want to look at the graph for this. So I'm going to kind of switch between the two. But sine is 1, so this is basically asking sine of x equals 1. What's x? So both of these give you the same value. If you go to the graph, sine of x is 1, so right there at pi over 2. So the inverse sine of 1 is equal to pi over 2. Okay. The next one, you're going to have to go a little bit off of memory because it's hard to read our 1/2, but it wants to know the inverse sine of negative 1/2, which would be right about here. And if you remember, pi over 6, if you plug that into sine, it's 1/2. We need it to be between negative pi over 2 and pi over 2. So negative pi over 6 is the inverse sine of negative 1/2. Not 7 pi over 6, not 11 pi over 6. It needs to be negative. It needs to be between negative pi over 2 and pi over 2, which this is. Inverse sine of 1/3, we don't have that memorized, and it's a gross decimal, so you're just going to type it in your calculator. To get inverse sine, you hit second sine, which then comes up with the proper notation. Do not do 1 divided by sine. Remember, that's not the same thing. That's going to be cosecant, not the inverse sine. So we want 1 divided by 3. Make sure parentheses. 0.34. And just make sure you're in radians, because it asks for that. So radians. Other than that, you're not going to be able to get a better answer, because 1/3 isn't a special triangle that we talk about. All right, so cosine has the same issue. So I'm gonna go through this one a little bit quicker. But cosine from, sorry. So already you should be able to tell this will not pass the horizontal line test. Oh boy, I messed up. Ignore those dots, I messed up. Okay, so this is the graph of cosine from negative pi to 5 pi. And again, not going to pass the horizontal line test. So we need to restrict it. Cosine makes a little bit more sense because it starts at 0. We remember our problem when we pick our interval is to go from a maximum to a minimum or a minimum to a maximum. In this case, we start at a maximum at 0, 1. So we can just start here, and then we can go clockwise or counterclockwise on the unit circle and get to pi. So from 0 to pi, we have all of the y values needed to cover the range of cosine, and we have a continuous interval, or a continuous function in this case. It's 1 to 1, so we have everything we need. This is cosine when we're talking about the inverse of cosine. So to look at some examples, inverse cosine of 0, if we go here, is pi over 2. So we'll use it, pi over 2. Negative root 2 over 2. Now we don't go backwards. It's not negative pi over 4. It's not negative 3 pi over 4. We need to pick a number that's between 0 and pi. And the negatives are beyond pi over 2. So 3 pi over 4 is going to give us negative root 2 over 2. 3 pi over 4. And then back to our graphing calculator. So inverse cosine of 0.6, 0.93. Next, we're going to go through tangent, which, again, has very similar problems. This time, they're a little bit different problems. But same idea. So, going to cut to the chase. This is not going to pass the horizontal line test just because all of these types of functions are cyclical. You're going through the same thing every single time. So pi over 2 is where it's undefined, so just every 4 lines. This is pi over 4. Negative pi over 4 is 0, pi over 4. And we have this happening over and over and over. And one more. Okay. So it'd be really nice to, again, get the full range of tangent. We don't want to cut any of that off because we need to have everything included that's possible. But we don't want to include more than we need. This one has actually some really nice breaks to it because of our asymptotes. So basically we're going to pick one of these sections. And again, we like to go through our y-intercept if possible. All the other ones go through the y-intercept. We also kind of want a combo of cosine and sine because tangent can be created by those two. So there's just a lot of things going into this that make us want to choose this interval right here. So this little chunk is going to be our tangent when we're talking, ignore that one, when we're talking about inverse tan, we're talking about this little chunk. This isn't inverse tan, but this is the portion of tangent that we look at when we're finding the inverse. So we restricted from negative pi over 2 to pi over 2 to keep a continuous set of values within tangent that covers the entire range. So going here, tangent is 1 when sine and cosine are the same value. They're the same at pi over 4. So inverse tan of 1 is pi over 4. It is negative root 3 on the left-hand side of the y-axis, so it's over here when sine is negative root 3 over 2. Sine is negative root 3 over 2 at negative pi over 3. That keeps cosine positive, sine negative, so it's going to create that negative value. But negative pi over 3 should be the answer there. And then back to the calculator. 0.2. And then rounding that, we're going to get about 0.20. And that's about it to inverse trig. Just be able to check on your calculator. So a lot of times you're going to be given these types of problems and you're just going to have to trust your calculator and make sure that, and you don't really have a way of knowing. I have no idea if inverse tan of 0.2 is actually 0.2. I assume because calculators haven't really lied to me before unless my settings are off, like if I have it degrees and it needs to be radians or the other way around. It's hard to know if I'm just being lied to or what. So being able to check is always nice. Exact answers for this. So sine is negative root 2 over 2 at negative pi over 4. It's also there at 5 pi over 4, 7 pi over 4, all of the stuff below the x-axis that creates that root 2 over 2 ratio. Now, checking to see if this is right is kind of gross, but you have to go inverse sine of negative root 2 divided by 2, enter. Perfect, negative pi over 4. If you don't recognize that, I wouldn't, but you can, first of all, just see, does that work? Does it seem logical? Is 3 divided by 4 about that? Yes. So it makes sense if you're just rounding, but I wouldn't recognize that and just say, yep, I got the right answer. So either I'd kind of say, well, is that about 3/4? Yes, it is, and then I'd be okay with that. Or you do still have your calculator. You can actually type in negative pi over 4 and see, is it the same decimal? And it is. So we got the same answer. Your calculator is not going to use pi because it doesn't like to recognize pi within the calculations. So just make sure you're checking your answers every now and then. Just see if you're on the right track. See if your calculator needs to be adjusted. But other than that, it's nothing to it. And that is it for this lesson. We're going to spend 2 days on this. This being day 1. Day 2, we're going to just get into more practice around the idea of domain and range and then evaluating these functions. But until next time.